In this video, we want to learn about reduction formulas or lowering power formula for trigonometric expressions. Here we have a list of these formulas. These are the formulas that can help us to write any trigonometric expressions involving even powers of sine and cosine in terms of the first power of cosine only. If we look at these formulas here, you can see that in the right side of the expression, in the right side of the formula, we have only cosine. So as you can see, we can write sine to the 2 in the form of 1 minus cosine of 2 theta over 2. Cosine to the 2 is 1 plus cosine of 2 theta over 2. And tangent to the 2 is 1 minus cosine 2 theta over 1 plus cosine 2 theta. So with the aim of these formulas, we can write any trigonometric expression involving sine and cosine with even powers in terms of first power of cosine only. In these formulas, these two are the most important formulas that we need the most. And we need this technique for lowering the powers, especially in the calculus. So we learn this technique especially for the calculus. But before I show you how we use these formulas to lower the power, let me explain you where these formulas come from, and then I will show you how we can use them. If you remember the double angle identity for cosine, cosine of 2 theta is equal to cosine to the 2 minus sine to the 2. This is one formula that we have for cosine of 2 theta. But we had another double angle identity for cosine 2 theta, which was basically this, 1 minus 2 sine to the 2 theta. If we solve this for sine to the 2, we have, if we move sine to the 2 sine to the 2 to the left, and we move cosine to the 2 theta to the right, then from this relation we have 2 sine squared theta equals 1 minus cosine 2 theta. So from the double angle identity for cosine 2 theta, we have this relation here. Now, if we divide both sides of this relation by 2, then we have 2 sine 2 theta over 2 equals 1 minus cosine 2 theta over 2. 2 from denominator with 2 from numerator cancels, and we have sine to the 2 theta is 1 minus cosine 2 theta over 2. And if you pay attention, this is exactly the formula that here we have for sine to the 2. What about the other formula? If you remember, we had another formula for cosine of 2 theta. The double angle identity for cosine has 3 different formulas. The other formula for cosine was 2 cosine to the 2 minus 1. Here, if we move 1 to the other side, or if we add 1 to the both sides, then from this relation we have 2 cosine to the 2 theta equals 1 plus cosine 2 theta. Simply move this to the left, and you can get this relation. Now, if you divide both sides of this relation by 2, then these 2 cancels from here, and then in the other side we have over 2. And this is exactly this formula. What about the last formula that here we have? Tangent to the 2 is 1 minus cosine over 1 plus cosine. How we can derive this formula? This one is really simple to derive it. Basically, for deriving this formula, simply if you divide this by this, if you divide left side to the left side and right side to the right side, you can derive this formula easily. Let me show you how this happens. Sine to the 2 theta over cosine to the 2 theta, based on these formulas, is 1 minus cosine 2 theta over 2, and cosine to the 2 is 1 plus cosine 2 theta over 2. If we simplify this, attention, here we have a division. To divide numerator by denominator, we know that we have to write the numerator divide by denominator 1 plus cosine 2 theta over 2. When we want to divide two fractions, we know that we can change division to multiplication. So we change division to multiplication, but we have to invert the second fraction. If we invert, we have 2 over 1 plus cosine 2 theta. 2 with 2 cancels, and we have 1 minus cosine in numerator, 1 plus cosine 2 theta in the denominator. And this is exactly this formula. This is the way that we can derive these formulas with double angle identities. And it's good to know how to derive these formulas because you don't want to memorize several formulas. If you know how to derive them, whenever you need these formulas, you can derive them by yourself. The other thing that is important that I should mention here is that between these formulas, these two first ones are the most important ones, and this one is not really important. And almost never we use this formula in the calculus. These two, we use them for finding integral of sine to the 2, cosine to the 2, sine to the 4, cosine to the 4, and other trigonometric functions involving sine and cosine with even degrees. But for finding integral of tangent to the 2, we almost never use this formula. So this one is not really important. But anyway, it is one of the formulas for lowering the power or reduction formulas. The other thing that I have to mention here is that one problem that many students have is that they think that if they memorize this formula, then they can use this without any problem. But they have to understand the formula. This is the most important thing. If you just memorize something, or if you learn how to derive it, if you cannot use it properly, it's not going to be helpful for you. What I mean by this? Look at this. Suppose you have this formula and I'm asking you what is sine to the 2 of 5x, because not necessarily always we have theta here. Maybe we have something other than theta, another angle. How we can write this expression which has sine with even degree in terms of cosine with degree 1? If we want to use this formula, the answer is 1 minus cosine of double of this angle. Attention, here is theta, the other side is 2 theta. Double of 5x is 10x divided by 2. So you should be able to write any sine or cosine function with even degrees with the aim of these formulas in terms of cosine with degree 1. If you pay attention to this side, we have a cosine with degree only 1. Let me ask you another question. What about cosine to the 2 of theta over 2? If we want to use this formula to eliminate this power, this equals 1 plus cosine of double of this angle. 2 times theta over 2 is theta, so this equals 1 plus cosine theta over 2. So, I highly recommend you, whenever you learn an identity, not only in trigonometry, any identity that you will learn in any topic, you have to understand how to use it. This is the most important part. Not just memorizing the formula would help you. You have to understand how to use it when you need the identity. Now let's do our first example. We want to write this trigonometric expression in terms of cosine of the first power. So we want to write this in terms of cosine only. And the terms that involve cosine, the degree of the cosine should be 1. It should be clear that immediately for doing this question, we can substitute sine to the 2x with the aim of this formula with 1 minus cosine 2x over 2. Cosine to the 2 is 1 plus cosine 2x over 2. We use the other formula. Now, of course, we have to multiply numerator by numerator, denominator by denominator, and then we have 1 minus cosine to the 2 of 2x over 4. But is this our final answer for this question? No. Remember, we want to write this trigonometric expression in terms of powers of 1, the first degree of cosine. But here, if you pay attention in our answer, we have cosine, but the power is 2. We want to eliminate all the even powers and we want to have only degree 1 for every cosine. So we have to do something here again. Before using this formula for this cosine to the 2, let me rewrite my answer in a little better form. Note that we have 1 minus cosine to the 2 of 2x all over 4. When you have something like a over 4, please attention, when you have something like a over 4, this is the same as 1/4 of a. So we can consider this expression as 1/4 of 1 minus cosine to the 2 of 2x. And if you want, you can multiply 1/4 in the bracket, which is not a bad idea really, but it's optional. Let me multiply 1/4 in the bracket. This is 1/4 minus 1/4 of cosine to the 2 of 2x. And attention, you don't need really to write this step. Simply, if you divide 1 by 4, you have this expression, and if you divide this by 4, you have this term. But maybe in this way it is more clear. Now, here, for this cosine, we use again the reduction formula for cosine. Remember, cosine to the 2 is 1 plus cosine of double of the angle over 2. So based on that formula, we can write this in the form of 1/4 minus 1 over 4 times by 1 plus cosine of double of the angle. Double of 2x is 4x over 2. And now if we multiply 1/4 in the bracket, 1/4 by the fraction, multiply numerator by numerator, denominator by denominator, then we have 1 over 4 minus, attention, we multiply 1 in numerator, so numerator is the same. But if we multiply denominator by denominator, in denominator we have 8, because 4 times 2 is 8. And this can be our final answer, but we can simplify this a little. Let me show you how we can simplify this. This is 1 over 4 minus 1 over 8 minus cosine of 4x over 8, which is better to be written as 1 over 8 cosine of 4x. 1 over 4 minus 1 over 8, if you do a common denominator between these two, it would be 1 over 8. 1 over 4 minus 1 over 8 is 1 over 8. So the final answer is 1 over 8 minus 1 over 8 cosine of 4x. So this expression is equal to this expression. But why we like this expression more than this expression? Because later you will see that in calculus we can find integral of this expression easily, but finding this expression, integral of this expression, is very difficult in this form. So for that reason, we rewrite that expression in this form. And the idea is to lower the power. Another way for doing this question, to write this expression, this particular question, is to use a trick here. Let me remind you the double angle identity for sine. Please attention, this is the normal way, the standard way to lower the power of this expression and get this answer. But for this particular question, we have a special method that I want to show you. Maybe it's not bad to see this as well. Let me remind you, double angle identity for sine. If you remember, sine of 2x is 2 sine of x cosine x. Now if we divide both sides of this relation by 2, we have 1/2 sine of 2x is sine x cosine x. We divide left side and the right side by 2 and we get this. So based on this relation, sine x times cosine x, sine x times cosine x is 1/2 sine of 2x. So we can use this relation for our expression here. Let me show you how. Sine x, sine to the 2 times cosine to the 2 is basically sine x times cosine x, all to the 2. We can use this formula and we can write sine x cosine x as 1/2 sine of 2x. So this equals 1/2 sine of 2x, all to the 2. And this equals 1/4 of sine to the 2 of 2x. We raise the expression in the bracket to the power of 2 and we have this. Now 1/4 is a coefficient, leave it here. Sine to the 2 of 2x, with this reduction formula, sine to the 2 theta is 1 minus cosine 2 theta over 2. If you use this formula for this, we have 1/4 times by 1 minus cosine of double of the angle. The angle is 2x, double of that would be 4x all over 2. Now if you pay attention, this answer is exactly the answer that we had in the other method. This is exactly this. Multiply denominator by denominator is 8. Multiply numerator by numerator, it would be exactly this. So finally we have this equals 8 in the denominator. 2 times 4 is 8. Multiply numerator by numerator and you have 1 minus cosine 4x. And this answer is exactly this. If you want, you can write this in the form of 1 over 8 minus 1 over 8 cosine of 4x. But this technique that I showed you for this question works only for this particular question. This method is more general. Now let me show you another example that we want to use reduction formulas to lower the power, and we want to write this in terms of cosine that its degree is 1. Here, if you pay attention, we have degree 4 for cosine, but the formula that we have is for sine to the 2 and cosine to the 2. If you remember what we have to do in this situation, when you have powers like 4, 6, 8, simply you can write this in the form of cosine to the 2 to a power. For example, cosine to the 4 is cosine to the 2 to the 2. Let's say we have cosine to the 6 theta. Then this is cosine to the 2 to the 3. So for any even degree, you can do this. And this technique is for even powers. So we can do this for any sine or cosine. Now, for the expression inside the bracket, we use the formula to lower the power. Cosine to the 2 based on the formula is 1 plus cosine of 2 theta all over 2 to the power of 2. The power is for everything in the bracket. 2 to the 4 is 2 to the 2 is 4, so denominator is 4. And numerator is 1 plus cosine to the 2 theta to the 2. 1 plus cosine 2 theta to the power of 2 is basically 1 plus cosine times 1 plus cosine. If you know how to use identity to raise this to the power of 2, then definitely it is better to use this a plus b to the 2 identity. But if you don't know how to raise the bracket to the 2, simply multiply the bracket by itself and you can find the answer. If you multiply the brackets by itself, then the answer would be 1 times 1, 1, plus 1 times cosine, cosine. Cosine times 1 would give you another cosine, so 2 cosine, plus cosine times cosine is cosine to the 2. So, in the numerator we have 1 plus 2 cosine theta, 2 cosine 2 theta, plus cosine to the 2 of 2 theta. Remember that I told you when we have a division by a number, we can write it as a coefficient. So we can factor this 4 and write this as 1/4 of this expression. 1 plus 2 cosine 2 theta plus cosine to the 2 of 2 theta. These two terms, we don't need to be worried for these because these are the things that we have and we don't have any problem with, because we have cosine with degree 1 here and this is just a constant. But this one, again, for this one, we have to use the reduction formula. So focus at this term. For this particular term, we can use the reduction formula again. But before that, let me multiply the 1/4 in the bracket. Then I will use the reduction formula for this term. So this equals 1/4. 1/4 times 1 is 1/4. 1/4 times 2 cosine is 1/2 cosine of 2 theta plus 1/4 cosine to the 2 of 2 theta. For this, if we use the reduction formula to lower the power, this is 1 plus cosine of 4 theta over 2. We can simplify our answer. 1/4 plus 1/2 cosine 2 theta. Multiply numerator by numerator, denominator by denominator. By multiplying denominator by denominator, we have 1/8 of 1 plus cosine of 4 theta. We have a 1/4 here. 1/8 times 1 is 1/8. 1/8 plus 1/4, if we do a common denominator between 1/4 and 1/8, the sum of them is 3/8. So this equals 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. And this is the final answer for this expression. As you can see, now we have written this trigonometric expression in a form that involves only cosine, and these cosines have degree 1. I hope by watching this video you have learned how to lower the powers of trigonometric expressions, and you can use this technique for integration in calculus. If you like this video, please subscribe in my channel and see you in the next videos.